And the title for this presentation, Cookbook, React Hook for rendering large list of elements, of DOM elements at the same page. So let's open our cookbook. Today, I would like to cook the following dish for the main course, rendering large list of DOM elements at the same page. A few words about myself and why I decided to cook exactly this dish. First of all, I'm senior UI engineer. As UI engineer, I have to feed a large family, a lot of users, a lot of site visitors, and I have to feed them all. So I have to cook a lot. I really have to cook a lot. It's a head. And but they're very hungry. They're very hungry. They're hungry for a lot of data. From the perspective of UI developer, they are very hungry for a lot of DOM elements to be rendered. So they ask for more DOM elements, for more DOM elements, more, or even more. So what exactly should I cook for them? Okay, so I have to cook something like this. It is standard React component, which will render 1,000 or 10,000 or even more heavy components at the same time, at the same page. And these components are wrapped with div element with class name list. As we can see, it is everything that we need. Seems that it's everything that we need to feed our large family. So a lot of components, and they're rendered in the same list. But actually, it is a very high calorie dish. It is very high calorie dish. Rendering these components at the same time can easily overload your CPU and CPU of any user. So we need to cook something lighter, not so heavy, not so fat maybe. We need to cook vegetarian option of our dish. Vegetarian option means that we need to lazy load heavy components only when they are displayed on the screen. So we need something like this. We need to achieve something like this result. The red border, it is our screen, we can say, and thousands of DOM elements to be rendered only when they are at the screen. So as you can see, when they're on the screen, they are rendered. Otherwise, we return the fallback. In our case, it is just a string, not on the screen, but anyway, you can render any fallback that you need. So we need something like this. Okay, so vegetarian option. If you need to display a large list of data efficiently, for example, you have thousands of listings to be rendered on the page. You should not render them at the same time. You should render only the items that are currently on the screen within a scrolling viewport. That means you don't need to pay the cost of thousands of rows of data being rendered at once. So let's take a look at our cookbook. What vegetarian option of our dish do we have? The first recipe, use common libraries. Okay, there is a recipe from one very popular cook, very popular developer from home, Money, with the following ingredients: npm packages React virtualized and React window. Highly recommend to get acquainted with the Money's recipe, and the link to YouTube video will be at the end of the presentation. But it is very cool, good solution, but it contains lactose. What does it mean? It contains lactose. So that means that the realization when conflicts with some of npm libraries in, we can say, large, not trivial projects. As for me, I have such project, and my project has lactose intolerance. I have some dependency of my box libraries. I remember that conflicted with some of these recipe solution, with some of these libraries. What about the price? The price is not so expensive. It is 140 kilobytes. It is not much. It is not really much, but for the projects that fight for any kilobyte in the bundle, it could be expensive. So there is another recipe, simple, illustrative, practical solution that we can implement it by our own, that we can cook by our own, with the price of only 1 kilobyte, which fits everyone, lactose intolerance free, so without any npm libraries conflicts at all, with the following ingredients: React hook, React hooks, and highly recommend to use TypeScript, but for the goals of clarity for this presentation, I will skip it. So let's cook it. What do we have? As you remember, we have this component, list component, with, that will render thousands or even more heavy components at the same time at the page that are wrapped to div with div element with the class name list. So we have the initial state is this. So we have this. Step 2. Let's heat up the stove and cook SubLoad component, or prepare a SubLoad component which will be responsible for rendering item if they are in this screen. So it is standard React component, nothing crucial, nothing new, and so on. We just moved our import to this component. Import some heavy component or any heavy component that you need. We put it here. And when the water boils, add the main ingredient. It means when the component on the screen load or render heavy component. It is really easy. When it is loaded, we will, or on the screen, we will render some heavy component. Otherwise, we will return this fallback. So that is everything that we need. We can pass any data to this heavy component. But how do we determine that it is on the screen or not? So how do we determine that it is loaded? We will use UseSubload hook. It is our custom hook, and which will return a loaded state, which determines whether the component on the screen or not, and which return a reference to the element which will wrap our heavy component. In our case, it will be SubLoad, this SubLoad component, and reference to this wrapper of our heavy component. So all the magic should be in UseSubload hook. Let's take a look at this hook. Actually, it is not a standard, but custom React hook based on standard React hooks. Use effect, use state, and use reference. Everyone who works with React hooks knows these hooks. So we need to use state for changing state of our loaded, which determines whether the component on the screen or not. Once again, we use ref for the element to the reference, in which we will have our heavy component, for which we need to determine whether it is on the screen or not. So it is just a reference to our wrapper to heavy component. And what spices do we need to add? We need to add the following spices, properties: container selector, string, query selector of DOM element, the root parent node element where our items should be rendered. In our case, as you remember, it will be list element, class list selector. The second property, handle loading, optional variable, which determines to return back state loaded to unloaded when the element leaves the screen. It means when our component is loaded and will leave the screen, the viewport, we will unrender our component, not to keep it in memory or in CPU memory or everywhere, but it is optional property. So the logic will be implemented thanks to intersection observer API. We will use its method observe, where we will pass our reference to our element. The intersection observer have two parameters. The first parameter is callback, in which we will get all the entities that we need to check the intersection with the root parameter, which is the following element. In our case, it is list parameter. So the API of intersection observer is very simple. It provides is intersecting property for any entry that we need to check the intersection without root element. It could be any wrapper or body or div, or everything that you need that you will pass to as container selector. And if it is intersecting, it will change the loaded state to true. So that is it. That is mostly it. Of course, we can also use handle loading property, which will determine to unload our component or no when we will leave the focus from when our component will leave screen. Highly recommend to use this property as true. So just add these 4 lines of code, which will set loaded to false. Mostly it will be set loaded to false when we once again leave this the screen area. Also, we can also settle some additional parameters to change margin for intersection of our DOM element. For example, here we use root margin with some margins. For example, we can use 100 pixels margin for our root element, and it is very convenient, simple, native, and powerful at the same time. So that is it. So we have the result. The initial state we have, as you remember, it is our initial component, and now we have our result component, where we substitute our heavy component import with import of subload component, in which we will pass container selector property as our query selector to our wrapper element. In our case, it is list, and any data that we need. In our case, I just pass item ID. It will be a number of index, but anyway, you can pass any data that you need as standard React component. And cooking process will be look something like this. So our component, where we will render thousands of subload components that will the subload component will load some heavy component when it will be on the screen or not. Otherwise, it will return some fallback. And to this determination of is the component within the screen or not will be thanks to UseSubload hook. It is the second part. And before the third part, before the finished part, we can add some garnish to provide the same result as we expected previously. So we just need to add list class and subload class to repeat the expected behavior. So it is our red zone, it is our list wrapper. You can see it is a list wrapper here with max height of 300 pixels, overflow with overflow auto. It is our zone that we need to render. We determined that only here we need to render components. And our subload component means height of 100 pixels. Up to you. You can set any properties that you need for your some heavy component and so on, but the common sense you could understand. So we will repeat the result that we expected. And all the magic, once again, will be held in this custom hook, UseSubload hook with intersection observer API. So that is it. So I definitely choose this recipe for my main dish because it is light, it is cheap, fits everyone, tasty, and very healthy. So summary: respect users' CPU, use common and ready-to-use libraries and packages for small and standard projects. You understand what I'm talking about. There is no standard projects, but we can understand the meaning of this phrase. And for large, heavy projects, always pay attention to the package size and consider of investigation to implement your own but simple solution. Of course, you don't need to reinvent the wheel. If it is not simple, use some ready-to-use solution. And bon appetit, it is a recipe that you can cook by yourself, full recipe, and the link to the example is provided. It is a working example at CodePen. The CodePen example is available by this link. It is Osman is introducing video to React virtualized and React video and pen packages. Also, highly recommend to get acquainted with this video. And the text version of this presentation is available by this link. I hope there are no. I hope it is. Yes, it is available there. Okay. So QA session, guys. Does anyone have questions?
Yeah, thank you, Alexey. And I see one of the questions from section is: in what case this solution is better?
Yes. As for me, it is better when you have scrolling on every time scrolling. So when you scroll your some, for example, lists, for example, I will answer the another way. There is lazy load property. It is provides for images, videos, and so on. Not all browsers support this property, but at the same time, it is very powerful and it will be supported by many properties. But in our case, we don't need it for images. We need mostly for another some heavy React components. For example, if you have a React component, it will be, for example, fully encapsulated GraphQL component that will make a lot of requests, or one request, heavy request, or not heavy, or simple request to database. If we will render this heavy component, all these 10,000 heavy components, for example, we have here offer component with ID X, Y, Z, and so on. And when it will be rendered, we will provide a request to backend where we'll, thanks to, for example, GraphQL, we will return the data for this component. But if we will leave it as it is, there will be 10,000 requests for each heavy component. But when we need to, if we provide lazy loading for these components, we will do only once again 3 or maybe 4 or 5, not more, requests at the same time for the backend, and we will not abuse our CPU of the user, CPU of the backend, and member of the backend, and network interaction with front-end backend interaction in my case. So it is one of the examples, but as for me, I really faced with several examples of such implementation. That's why I prepared to implement this solution for my needs. So it really helps me a lot to prevent or abusing, overloading of a lot of network requests, a lot of loading, fetching data. For example, if every of our components, images, and so on have, for example, a request to image from Amazon S3, for example, or other clouds, we will do a lot of requests. And usually we don't need so many requests. We need only the request for the area where we want to, for the screen area. So I hope I answered the question.
Okay, thank you. Waiting for another questions. Yeah, again, I like to try being a devil's advocate a little bit. So another case, a real life case of mine, where we decided that, yeah, this approach less abusive for backend, but the most probably, yeah, less abusive, because it depends on additional requirements around this list. Like in case you should filter something or sort, these requests most probably will be sent to the backend to filter the list, because on the front end, at that moment, you won't have all the data. So yeah, that's kind of from case to case.
Yes, for example, we have a list of IDs, only IDs, not data, because we have ID 1, 2, 3, and 4, and so on, and 10,000 of such IDs, and we just have IDs, but we don't have some additional information, because, for example, description, title, very heavy information we can have. For example, it could be article with very big article, or even medium weight of article, but anyway, it will be another responses, another requests to backend, even for description, and it will for sure abuse our CPU or even overload our CPU. So we just need these IDs. We can pass our IDs here, and these components, for example, some heavy components. It is also a topic for another discussion, because with, for example, GraphQL, we could provide really encapsulate components which are separate from another logic. So we have our parent component, and this parent component will render some heavy component, and heavy component now knows nothing about the parent components. It's just waiting for ID. For example, we get the ID of 5, and we make all the preparations with, for example, once again, GraphQL or JSON or HTTP, another HTTP JSON request, and we get, for example, description, titles, and so on and so on and so on, and we will we don't need to provide so many requests to backend at the time, and we don't need to to prepare JSON with all the data here for this component. We just need IDs of it, and it is very good recipe for, I can say, fully encapsulating components paradigm or pattern of implementing. I hope you understand what I'm talking about. So something like this.
Cool, makes sense. Thank you. 1 sec. Yeah, Victor.
Hello. Thanks for the summary. Have you compared the React window, React virtualized to intersector API? Is it equal?
Actually, I highly recommend to get acquainted with the solution of Adios Money. And as I remember, it was several, maybe about 2 years ago, I faced with this problem. But it is not, it is mistake in our presentation, I can say, because it is, it was not otherwise, it was not either React virtualized, either React window. In his solution, he suggested to use them all. So we use as well as React virtualized or React window at the same time. As I remember, I can forget this topic, this not topic, but this case. But as I remember, there was a mix of these two libraries. But and as I remember, you can't. Maybe 2 years ago it was, but you can't solve your problem only by one of these library. They are separately, they have their sense, their goals to be implemented, but at the same time, for my current goal, for my current implementation goals, I have had to use them both, and then I understood that I can replace this implementation for these both libraries with this hook that I provided.
Yeah.
So
thank you for an answer. Yeah, React virtualized is like a big gun, and React window is a small gun for some specific problems, because React virtualized has very useful hooks and other stuff. And by the way, my work recently, I have come to same solution that was talked by Alexey, or I don't remember. So yeah.
Yeah, it's just a recipe, and of course the recipe can differ one to each other, but anyway, sometimes we can provide not just another npm package, but sometimes it is more cheaper, sometimes even, or simple to implement some, especially now with React hooks, some your own decision, your own solution. So yes, it was just a recipe. You can, for sure, you have the same recipe. You have another recipe for the same dish, as I understand. So yeah, just
we exchanged rendering large lists for requesting cheap indexes, list positions from the backend, and exchanging often, and rendering positions on the front end. So you have 10,000 of positions, they begin rendering, and when the component goes into viewport, you request the data. For some time, we decided to use throttle, and after that, your component gets loaded.
Yeah,
something like that.
Actually, if I'm not mistaken, current Facebook version was based also not exactly on the same pattern, of course, but they have something like this. They have separated encapsulated components which have their own responsibility, and they work only as soon as they are triggered for a screen, for example. So when you have a feed in Facebook and you scroll down, and we have firstly we have maybe some fallback layout fallback, and with some gray colors we remember, and and there is a request to backend, and we got this information. So it's mostly about that we can, as front-end developers, we can now mostly work to the direction of encapsulating. As for me, GraphQL, it is topic for another presentation, of course, or even talks, or even several talks, that GraphQL is as good as the advantage of GraphQL is it is really easy to implement such pattern. Not really at all, but it is really and very good solution for such pattern when for encapsulating of components. That is my point.
Okay, thank you. Anyone else? Yeah, I see the comment about one hook is anyway better than one external library. Yeah, most probably. I just wanted to say that the last point of the last slide, a bit questionable for me about the weight of the package, because mostly yes, that the weight of package is important. Just maybe for hooks, it's not the case of discussion. Just if we're talking about like some projects where we have different stacks, different patterns, and they are decided to use one library, even if it's big, just because it is some kind of standard of the of everything. I don't know, like just referring to recursionalized size.
Exactly. Yeah.
Yeah. And
different projects have different solutions, of course, but it's, sometimes, as for me, I had such situation when reducing of 100 kilobytes was something like winning in some difficult battle. So yeah, it depends on the project, of course. But really, React Virtualized and React Window, good solutions, you can use it. And I really highly recommend, first of all, to use as for me, it is better to use prepared, ready to use, and checked out by time solutions than reinvent the wheel. But for such particular case, there is a recipe from my side.
Great. Thank you.
Thank you.
Okay. Yeah, I'm not seeing any other questions anymore. So I think that's kind of it. We can just wrap up. So yeah, guys, thank you. Thanks a lot for participants today in our Dynamic Talks meetup.